All right, 3.1. I got to be up here today a little bit more than often than I am because, you'll see why. 3.1, graphing quadratic functions. We're moving up in the world. Yeah, this is the fun stuff. Okay, quadratic function. Definition of it is a function with the greatest exponent being 2. Okay, so now we're moving up. Instead of all of your x's having just an exponent of 1, whether it was equations or a system of equations, now they're going to be 2. Okay, which changes a lot. And the part of the first half of this chapter, we're going to talk about what that all changes to it. All right, starting today with the graphing part. Highlight this part. This is important. All right, f of x equals ax squared plus bx plus c. F of ax squared plus bx plus c. Especially the a, b, and c part, because we're going to use that all day today. Okay, especially a and b. That's called your general form to a quadratic equation. All right, ax squared plus bx plus c. Okay, with that, you can graph any quadratic I give you. Okay, you can graph any of them. They have special names. Make sure you learn those. Okay, make sure you write those down. The first one is called your quadratic term. Excuse me, that's the one that's on ax squared. The middle one, bx, that's your linear term. And then c is called a constant. Okay, it's important to make sure you know, because those are the words I'll use. Okay, a, b, and c, and then look at your quadratic term, look at your linear term, look at your constant term. Okay. We kind of talked about this one last chapter, a parabola, right? What's a parabola look like? What kind of shape? A U. Okay. Either a U or if it's flipped, right? Mountain kind of deal. All right. A parabola is the graph of a quadratic function. Okay. So make sure you know the main thing on this one. Make sure you know where A and B are at. Okay. Even if you ever see one where the parts are flipped, like x goes first and x squared goes second, you need to rewrite it so that bx is like ax squared is first, bx is second. Okay. All right. Savannah, you going for cough drops again? All right. Everybody good? Next slide. Another one you pretty much already know, axis of symmetry. We kind of talked about that last chapter also. It's a line that the line goes through the graph of a parabola, dividing the graph into two congruent halves. Right? We talked about that with line symmetry last time. You can fold it on top and it lays on each other. Okay, so we kind of know that already. The most important one here, though, is your vertex. This is key. Vertex is the only point the axis of symmetry will intersect a parabola. Okay, now, this is a little long-winded. Okay, so stay with me here. Your axis of symmetry, which is down here on this example, goes through the what of the graph? Starts with an M. The middle. Okay, goes through the middle. All right, axis of symmetry goes through the middle. The definition of a vertex is the only point the axis of symmetry intersects a parabola. Okay, so that means this axis of symmetry will always intersect the parabola at the vertex, which is also the middle. Okay, that vertex, when we go to graph these, will be the most important point you look for. It'll be the first point you look for. And the way you find that, yeah, I'm on drummer, is right there. Okay? Negative b over 2a. Negative b over 2a. That needs to be like tattooed on you someplace. Okay? I won't pay for your tattoo, but it needs to be tattooed on you somewhere so you remember it. Okay, negative b over 2a. Now, where did this a and the b come from? We got an idea? Savannah? The quadratic function, very good, sir. The ax squared plus bx plus c. Okay, that's where they come from. So whenever I give you a quadratic, you're going to look at it, identify what A, B, and C are, do negative b over 2a with it, and then go from there. Okay? You need to remember negative b over 2a. Alrighty? Questions on that? Make sense? Everybody ready to rock and roll with one? Okay, let's do one then. Alright, so your first one, graph f of x equals 3x squared minus 12x plus 6 by making a table. Alright, we're going to do a few other things before we actually go through and make the table, okay? And this is why. We'll work on it. The very first thing you do is identify A, B, and C. Okay? So this one's in nice order for you, so you're ready to go with that. There's A, there's B, there's C. Okay? Now, important to note, haven't mentioned this yet, the sign that's with them goes with, okay? So see how 12 here is negative? Okay? So that means B is negative 12. Okay? It goes along with it. All right, so your first step, we want to find that vertex, because the vertex is the what? The middle. All right, it's important that you find the middle of these graphs. All right, and I'll tell you why in just a moment. So we got negative b over 2a is step 1. So we got negative sign from here, and b is what? Negative 12, good. All over 2, and a is what? 3. So these two negatives become a positive, good. 2 times 3 is 6, and 12 divided by 6 is 2. Very good. Negative b over 2a. B is negative 12. Minus the negative. Makes positive. 2 times 3 is 6. Reduce it, you get 2. Okay. Now, that is the x-coordinate of your vertex. Okay? That's the x-coordinate of your vertex. Now, to get that point, we need to find that y. All right? Anybody got any idea how we might do that? Go back to your, let me think about this, 7th grade year. Okay, when you first started graphing lines, you would take an x, you would put it in to get a corresponding y, right? Remember that? Remember those days? Your teacher would say, here's 5 x's, put them in here, get their corresponding y's. Same thing here. Okay? That doesn't change whether you're talking about lines or whether you're talking about quadratics or whether you're talking about polynomials. Doesn't matter. Same concepts, okay? Because remember last chapter where we were talking about relationships of numbers? Okay, how they're related, right? Linear relationship, whatever. These numbers are related by 3x squared minus 12x plus 6. That's how they're related. So to figure out that y-coordinate, you need to put 2 into this function. Make sense? So we need to go, I'm going to go up here on top. 3 times 2 needs to be squared, minus 12 times 2 plus 6. And from there you follow your order of operations. Alright, so exponents will go first. So we're going to square 2, which gives us 4. Three times 4 is 12. Minus 12 times 2, which is 24. Plus 6. Which ends up with, giving us, should be negative 6, right? So that goes there. 2, negative 6. Then we're going to go to our graph. We're going to plot that point. All right? And I'm going to make a big deal about it being the vertex. Everybody good with how I did that? Negative b over 2a. You do that first. And then you plug that number in to get your vertex. Okay? Now, your vertex is what starts with an M? It's the middle. Okay? Now, why is it important that we know where the middle is? Think about how it looks. Think about the shape of the graph. Why do we care where the middle is? No? No? That's kind of where you're going to start, right? And when you go either up or down from that, you're going to go up or down, and the graph is going to be what? Starts with S. Symmetry. Symmetrical. Very good. It's going to be symmetrical. Okay? So you need to know where that middle is, because from there, your point should be going up kind of like the same rate. Okay? So here's what you do next. You go from your x. Your vertex is 2, right? All right. Now we're going to graph it by making the table. Your x is 2. Your vertex is 2. So we're going to go 1 up, 1 down. So 1 up from 2 is what? 3. 1 down from 2 is what? 1. Okay? Then you're going to go 2 up and 2 down. So 2 up from 2 is 4. Can you put a what? Yeah. Yeah, 2, and then 1 up and 1 down from 2 is 3 and 1. And then 2 up and 2 down from 2 is 4 and 0. Okay? Now, here's where you're going to have to trust me for just a little bit. Okay? Because I want to show you the graph without getting rid of all my drawing. All right? The numbers are -3 and -3 and 6 and 6. That was really quick, right? Really fast. I'm really good. How could you get those? Anybody know what I did? Yeah, that's one way, okay? That's exactly right. You take these numbers. Now, the reason why you go 1 up and 1 down and 2 up and 2 down is because you need to get 5 points that your graph looks good. Okay? You can get these numbers by plugging in 3 to this function and evaluating, by plugging in 1 to that function and evaluating, 4 in, 0 in, and figuring out what they all are. Basically, you're doing this work 5 times. Okay? But hold that thought. All right? What I want you guys to do is finish this graph up, though, right now. And I'll show you what I did, because you're not going to be doing that work. So 3, -3 is right there. 1, -3 is right there. 4, 6, 0, 6. Okay? If you have 5 points that fit on your graph, I want to see 5 points. Okay? You won't always have 5 points that fit. Sometimes they'll just be 3. But if you have 5 points, I want to see 5. All right. Now, I know these are kind of hard to draw. Okay? I'm not the best at them either. I'll probably miss a point every now and then. Just do your best. All right? As long as the table looks good. As long as you're like close. Like, see how I kind of went wavy right there? See that? I didn't exactly hit it. I'm not taking off points for that. Okay? As long as you get it close, that's good. As long as it's basically in the right side, right direction, stuff like that, I'll be okay. Okay, but just make it as good as you can. Okay? That's how you do one. But that doesn't answer everybody's burning question yet, does it? How did Mr. Mormon come up with those 4 numbers so fast? Cozy. And then I did what? Hit second graph. Exactly. Okay? That's the beauty of this. Everybody got this down? Everybody good up here? Fantastic. just like we did yesterday. All right, let's clear that one out. We don't need it. You're going to put this in. All right, so 3x squared minus 12x plus 6. All right, 3x squared minus 12x plus 6. See, they're fascinated. All right, 3x squared minus 12x plus 6. Everybody good? Okay, hit graph. Hopefully it looks like the one we just did. All right, that's cool. Now, looks pretty close to what we just drew, right? Okay, but all you have to do, once again, go second graph, and that brings up your table. All right, now for whatever reason, mine is at -7 and 237. Whoa boy, that's not on my graph. So this is why you find the vertex first. Okay, this is why. Because if you just go straight to your calculator, you're going to have no clue as to where your middle is. Okay? So you find your vertex first. So we know on this one our vertex is what? 2, right? There we go. Now we're getting to some normal numbers. So you find that vertex first. Okay? After that, how I did the work, how I didn't find my vertex, and then I did my work to get the y part of my vertex, and then I just went to my table. You guys can do the same thing. Okay? So you don't have to show the work of you plugging in all 4 of those points. Because that's a lot of work. You show me that 1, and you go to your table, and you get those 4. Because those are the 5 points that fit on your 10 by 10 graph, right? Between 6 and 6 and 4 and 0. After that, you're at -1 and 21 and 5 and 21, and that's a little high. Doesn't fit. So that's why you need these. Okay? Because then I'm saving you so much work. You don't have one of these? You know what you have to do? You have to plug all 5 numbers in. Alright? And that's not even half of it for this chapter. As far as all you have to do without it. Alright? Questions? Make sense? Be okay?
Where you got the 12?
The first 12?
Yeah.
Oh, everybody good up here? Close. Discard. Wrong button.
Like negative b over 2a.
Well, the negative b over 2a is the formula. Okay, and then your -12 comes from that part.
And then the 2 times
2
3.
times 3, because 3 is a. Right? A is with x squared, b is with x, and c is with 1 by itself. Okay? Everybody good? Good. Do your... Okay, now, here's an example also. We're going to do this one together too. Or at least we're going to start it together. Here's an example also as to why it's important to find your vertex first. And not just go through the motions of plugging in your calculator and everything. All right? So we're going to do the same work. Okay? We're going to find A, B, and C. We're going to find our vertex. And we're going to go from there. Okay? So in this case, A is 1. Right? B is 5. C is -3. Whoops. So negative b over 2a. So b is 5, so -5 over 2 times 1, which equals -5 over 2, which means Mr. Mormon's giving us what? Fractions. No, just me? Just me? That's fine. Okay. But that's still your x-coordinate of your vertex. Okay? Now, here's something odd. Ready for this? Make that a decimal. Okay? Make that a decimal. So -5 divided by 2 is what? Negative 2.5. Okay. The reason why I want these as decimals is because negative 2.5, figuring out where that is on here, is way easier than 5 halves. Negative 5 halves. So this is where you have my permission to use decimals. Okay. But it's still your vertex, right? So negative 2.5. Okay. Now from there, after that, plug it into your equation. So x squared plus 5x minus 3. So negative 2.5 squared plus 5 times negative 2.5 minus 3. And from there, if you put that in your calculator just like that, you'll get the right answer. So negative 2.5 in parentheses, square it, okay, plus 5 times negative 2.5, and then minus 3, which gives you what, negative 9.25? Is that right?
What did you get?
I got negative 9.25.
Yeah.
Retry it, yeah. Okay, now here's where this gets a little trickier, all right? You have to know where negative 2.5 and negative 9.25 is kind of somewhat on the graph. All right, so if I go over here to negative 2, negative 2.5 is going to be between negative 2 and negative 3, yes? Okay, so it's somewhere in here. Now if I go all the way down to negative 9.25, it's probably somewhere right around here. Okay, probably right off the graph onto the PowerPoint part. Okay, I apologize. I thought these were negative by 10s, not 8s. Okay, so it's probably somewhere here. Point being is this. As long as you're somewhat close with that, I'm okay, because these won't come up all too often where your vertex is something ugly. All right, occasionally they will. The book likes that. I particularly not so much, but the book occasionally does. Okay, so if there's ever a problem assigned where one like this happens, you guys need to know how to handle it. And plus, it will come up later on in word problems too, so we still have to know how to handle it. Okay? But from there, the nice part is this. You still do the same thing we did last time. Okay? You still get the next 2 up and the next 2 down. But the nice part here is you don't have to do the decimals, you can still do the whole numbers. Okay? So the next 2 whole numbers from negative 2.5 would be negative 2 and negative 1. And on the other side will be negative 3 and negative 5. And then you still go to your graph on your calculator, like Cozy's doing right now, get those points off of your table. Okay, Booker.
How did you get the x's again?
You always go, you want to be around your vertex. So your vertex is negative 2.5, right? So you want to be about between, you want to go negative 2 and negative 3, because that's the 2 whole numbers that are next to it. And you want to go negative 1 and negative 5. Or I'm sorry, negative 4, not negative 5. Negative 4, negative 4. My fault. Negative 4. Okay. You don't want to go out to like positive 6. You understand what I'm saying with that? You go out to positive 6, your chances are your graph's going to be way up here or way down here, whichever way it's facing, and you're not going to be able to plot it anyway. So you always want to hang around your vertex with the numbers that you put on your table. Okay. So I always go 1 and 2 up, 1 and 2 down. Okay. Let's see. Those numbers would be what? Plus 5. Well, we got negative 7 for negative 4 and negative 1, right? And then negative 9 for these two. Is that right? So we got negative 2, negative 9. Okay, so my graph's not the greatest. and then -1, -7 like that. Ah, see, totally missed my points on that one. There we go. Okay, so like I said, it doesn't have to be super accurate. As far as, like, you know, if you miss the point just a little bit, that's fine. Just make sure your tables are good, make sure your points are good. All right, get the plot. Okay, here's what it looks like in the calculator, and this is going to be a little weird. All right, whenever you have decimal numbers like that. Let's see, x squared plus 5x minus 3. And we graph. All right, so pretty much looks, okay, ours is probably a shorter version than what's up here. Okay, but here's why you need to know, like, your numbers and, like, where they fall in between and stuff like that. Because if you go to your table's only in whole numbers. Okay, so you won't actually see the -2.5 and the -9.25. So you have, that's why it's important you find your vertex, because sometimes that's not going to work out to where it's nice. But you also know where -2.5 falls in your x number line, right? It's between -2 and -3. So whenever you know that, that's kind of where you need to head. So you still need to go towards where those your vertex is, even if it doesn't show up here. Okay, you know -2 falls between -2 and -3, so that's where you go to look at your calculator. -2 is -9, -3 is -9, and then -4 and -1 with your -7s. So whether it shows up or it doesn't, you still have an idea as to where it is. Make sense? Yes, no, yeah? Everybody good? Okay. Ms. Taylor, does that answer you? You good? Great. Alrighty. Alright, last kind of topic is this. We're going to touch, okay, and I mean touch, word problems with this later. Okay? And this is kind of where this leads into, is word problems. Okay? This one opens up. This one opens down. Everybody see that? Parabolas? Yes? Okay? Whenever a parabola opens up, it's got a low point, right? Okay? That low point is called the minimum. It's kind of a review from last chapter. So I'm going to go over, right? Whenever it opens down, it's got a what? It's got a maximum. Okay? Now, when you look at the equations for this, it depends on whether A is positive or negative. All right? If A is positive, like it says right here, ax squared, it opens up and has a minimum value when A is greater than 0. So look at this model, because that's going to really drive it home. If A is positive, then the graph opens up like this, and you got a low point. Make sense? That's like the two we've done already. Okay. If A is negative, it opens down, and you have a maximum. Either case, though, that max or that min is also your what? Starts with a V. Your vertex. Okay? So where this leads into is asking this. Determine whether the function has a max or a min, and then find it. State it. Okay? Leads into this last one. Okay? Determine whether the function has a max or a min value, and then state it. So basically, you find your vertex, which is how do you do that? First step is negative what? Over 2a, and then you do what? You plug that in. All right, so all you got to do if we want to state the max or the min is find the vertex. So negative b over 2a. b is 12. A is negative 4. So we got negative 12 over 2 times negative 4. which means you have negative 12 over negative 8, which ends up being 3/2 or 1.5. So that's the x-coordinate of the vertex. To find the y-coordinate, you take 1.5, plug it in. So negative 4 times 1.5 squared plus 12 times, I don't know where 2 came from, times 1.5 plus 18. Everybody get that far? Alright, so negative 4, 1.5 squared is 2.25 plus 12 times 1.5 plus 18. And once you clean all that up, that all ends up being what? 27. Alright, now the only thing we haven't done yet is say whether that's a max or a min. Bless you. Okay? Booker? It's a max. Why is it a max? No? It's not. Well, which one's negative? Hold on. Say again. Say a little clearer. Okay. Anybody know why? Cozy? A is negative. See how A is negative? Okay, so that's going to flip your graph to make it look like a mountain instead of a U. So then 27 is your max.